Hey, what's up and how's it going? This is Toby, and in today's video we are going to build this amazing cross-platform AR multiplayer experience using Unity and the Niantic Spatial SDK. And as you can see, this is running on iOS and Android and allows for true cross-platform multiplayer, which has been pretty tough in the past, but with some of the latest updates of Niantic Spatial SDK, formerly known as Lightship, we got some awesome new technology such as cloud persistence, as well as a completely custom networking system, which, by the way, I'm also using for the AR game that I'm currently developing called AVAs, where you have shared AR dogfights with airplanes, as you can see here, which is pretty cool. And if you follow this tutorial all the way through, you have all the basic knowledge to create your own shared AR multiplayer experience or game, which is extremely exciting. So without any further ado, let's get started. Before starting, I want to do some shameless self-promotion. If you're using tools like Claude Code, Codex, or any other AI coding assistant, consider checking out the Magic AI Wingman. It's a new Unity asset I made which creates LLM-readable reports of your scenes, prefabs, project settings, and so on, so that your AI of choice can fully understand your project while consuming minimal tokens. This tool also works great with the Niantic Spatial SDK and its multiplayer solution, and helped me to implement new systems and solve bugs in my own project. Link is in the description. Lucky for us, we don't need to start from scratch, but we can utilize the provided sample scenes from Niantic, and for that we can go to the GitHub link, github.com/Niantic-Lightship, but also put the link in the video description, and we can click here on ARDK samples. By the way, there's a lot of interesting, cool stuff here. If you have time, then take a look at that. So we can click on the ARDK samples, and then we want to select releases. And at the making of this video, the most recent version is the ARDK samples Unity project 3.16 Unity patch. And if you are watching this video in the future, there might already be a later version, and chances are good that 3.17, 3.18, and so on will still work with what we are doing right now. However, if you want to be safe, then use the exact same version of Lightship as well as the exact same version of Unity as I do. So next up, let's download all of these files here. So we can go ahead and download the source code here. And we also want to download the playback assets here because we're going to use them for in-editor testing. Next up, we need to make sure that the correct Unity version is installed, and for that, let's check in the Niantic Spatial documentation. So that's nianticspatial.com/docs. Again, the links are all in the video description. Let's click on the ARDK3, and then let's go under the getting started, and then setting up the Niantic SDK for Unity. And here we'll see what is supported. So if we scroll down a little bit, they say we support Unity 6 with 6.58 F2 and 2022 LTS. For this tutorial, we are going to use this exact Unity version here. So 6.58 F2, 6.0, however you want to call that. And so we want to make sure that this one is installed. And for that, let's open up the Unity Hub. If you want to know how to install Unity in the first place, I also made a tutorial on that, and I'll link it in the video description as well. Let's go to installs, and then we can see that in my case, I do have this editor installed, but if you haven't, you can go to install editor, and then chances are good that it's not the official recommended release, which is the latest one, because this would be 6.60 or maybe even 6.2. So we want to go to archive, download archive, and here we can go to Unity 6 LTS. And then we're going to see the 6.0 58 F2, and then we're just going to install that, open Unity Hub, and this is already installed. However, in your case, you're going to click on install, and then you want to make sure that you have Android build support and iOS build support ready. In my case, I'm on Apple Silicon Mac, so I already installed that, and you should also do that based on whatever computer you're using. Alright, so the next step, we want to make sure that we unzip the files we just downloaded and put them in a folder. I already created the Niantic multiplayer tutorial folder for me and put the files we just downloaded in here, and then we're just gonna unzip the ARDK samples. And by the way, this is a Unity project, so this is actually not just something that you might import into your existing project, but this is a full project we can open up. And we can do the same thing with our playback assets here that we are going to use later on, which essentially just contain a whole lot of images that we're going to use for AR simulation a bit later on. And then in the Unity Hub, we want to go to Projects. We're going to go to Add Project from Disk. And then we want to find the correct folder, select our ARDK samples, and simply then in this folder, click here on Open. All right, so this is basically the project, the samples we just added, and let's open that up. So then we will receive a warning that this project is using the new input system package and we'll need to restart the editor. So we want to click on yes and do a restart. So then we get a few more error messages. And first of all, let's click here on Open Package Manager. And in my case here, it's the JetBrains Writer Editor plugin, and I'm just gonna update this one. And if we close that now, we can see that, well, many of the error messages vanish. We can still see that there are two kind of error messages left here. This one we'll ignore for now, but this one has to do with the XR simulation and some kind of XR settings. And again, as we are opening up pretty much a full on Unity project, there might be always some kind of serialization issues and so on and so forth. Or some asset database issues. So what we want to do in this case is we want to again close the project. Then we want to go into the projects folder in our Finder or our Explorer where the project is stored. So this would be this path basically for me. And then we want to go into the assets folder and there's the XR folder. And we want to simply delete this one for now. And we also want to delete the library for now so that we have both of that deleted. And this will pretty much trigger the regeneration of the library. And we're just going to have a much cleaner and fresher start. So let's close the folder again and let's open up the project once more. Then we want to once more go to the Open Package Manager and it says that this package is not supported anymore. Let's remove that one. We don't need it for right now. And now we should be pretty good. So we only have one more error remaining, but we're just going to leave that for now as it's not really influencing our development here. You can see that also the XR folder kind of simply just reappeared here. So it was recreated automatically. And now we can continue setting up our project. So next up, let's set the platform we're building to by going on the top left here to the build profiles. And then we want to change from macOS to either Android or iOS, whatever you prefer. But again, we're going to build this as a cross-platform. So at some point, we're just going to switch in between those. But for the time being, I'm going to switch to iOS, but switching to Android and developing with Android selected would be totally fine. So once that has finished, let's go to our player settings. And then we want to go into the XR plugin management and we want to enable the plugin providers, which would be for Apple, Niantic plus Apple AR Kit. For Android, this would be Niantic plus AR Core. And for basically the PC, we do have two settings. So let's quickly wait until Unity is done here and make sure these actually have been selected. So yes, both have been logged in. And for PC, we either have the Niantic SDK for Unity Editor or the Lightship Simulation. Those are both valid options. We're gonna start though with the Lightship Simulation. The difference is essentially that the Niantic Lightship SDK will utilize kind of a video-based playback. So in the background of our game, we're going to see the playback of a camera feed. And in the Lightship Simulation, we're gonna have a interactive 3D environment that we can walk through to test our AR app. Both are really useful, but again, we're just going to start with the simulation, which is also triggering the XR simulation. So then next up, let's go down here to the Niantic Lightship SDK, and we need an API key. Lightship is generally for free if you test around with it. However, if you release the app to the App Store and you get a certain amount of players, then it's going to cost something, so be aware of that. But it's a pretty great tool and it's a lot of fun to work with. So depending on what you're working on, it can definitely be worth it. So what we want to do here is click on Get API Key, and then a website is going to open up. And you'll probably need to log into this page. I'm already logged in, so you can just create a new account. And then if you are on this dashboard, gonna click on New Project, then you could call it whatever you want. So something like AR Multiplayer or something. And then just copy the API key. And then go back to Unity and simply paste that one in here. This is important if we want to test out our multiplayer, especially for that. It's pretty important because otherwise we actually can't build it to device, and I think we can't even test it in the editor. Then below here we do have the playback section, which is also quite important. This is what I just wanted to tell you about. So essentially this is like a video feed, and I did actually some samples myself. But we are in this case going to use the samples that are provided by Niantic. And so we want to click here on the browse button. Then we want to navigate to the folder where we essentially just left and put our project files in. And here we can select either the Gandhi statue or the relic playback dataset. So essentially we just need to open the folder and click on choose. And as we can see now, it's loading in the playback. And if we're gonna later on select here in our XR plugin management, the Niantic Lightship SDK for Unity editor, we're going to see the video playback. But this is something we're gonna do a bit later on. All right, so next up, let's make sure that all the other stuff in our editor is working. And for that, we can already begin by opening up a sample scene. Again, this is pretty much, so what we opened just here, the ARDK samples, this is not only multiplayer, but this is essentially all the features that Lightship has to offer, or the Niantic Spatial SDK. So we do have here depth, meshing, navigation mesh, object detection. So if you have some more time, I also made a video about this sample scene package or project here. You can go through all these scenes and take a look what else is possible. But what we are going to essentially use here is within the on-device persistence in scenes, we want to have the cloud persistent scene. So this is essentially already a fully set up AR multiplayer scene where one person can create a map and another person can load a map with a certain name, and then both can connect essentially in a multiplayer space. Let's just, before we go into the functionality of the scene, make sure that our XR simulation is working. For that, we want to go to Window and then XR, AR Foundation, XR Environment. And here what we need to do is import the XR sample environments. So click on here and click on Install Sample Environments. And then we should see a pop-up. And this is going to say import Unity package, and then we're just going to click on import here. So then if we click on this globe button here, we are going to see essentially our all of our XR sample environments. So we can, for example, take a kitchen here, or a dining room or anything, and we can use this as a simulation of our AR scene and then move around with our camera. So we can just leave that on for now, and then simply click on X. And as we can see, we have some more error messages to solve, but this has to do with the current scene that we just opened. And I think this one has to do with some kind of font assets that have not been serialized correctly. So let's quickly go ahead and fix these issues so we can finally then build on our AR multiplayer project. So first of all, let's begin with this one. So this is something in the assets RCA folder. So let's go in here, and there seems to be some kind of asset file that has some kind of issue. So let's reveal that in the Finder here. Double click, and we can see that this should be the corresponding file, and let's simply go ahead and delete it. We don't need this anyways, and essentially this should be recreated if we restart the editor. So let's delete those. And then next up, let's do the same thing with something in here in the Text Mesh Pro fonts and materials. What we might be able to do here is to actually re-import Text Mesh Pro. So let's go to Window, Text Mesh Pro, and then we want to go to the essential resources and just click on Import. And then once again, let's go to Window, Text Mesh Pro, and Examples and Extras. And let's also import that. These are just some basically extra text components and UI components that are handy anyways. And as we can see, something did indeed change. And so we do have this JSON issue, which is not really affecting us too much, but there seems to be something that has to do once more with the current scene that we're in. So this might be here under the Text Mesh Pro fonts, and then so this was the issue, I guess. So let's reveal that in Finder, and there is the the noto sans jp.asset file as well as the meta file. Let's delete that, and maybe to make sure that everything that has been deleted might get regenerated, let's once more restart the editor. All right, and here we are in the scene with only our one error message left that we are going to ignore for now. All right, so now we can finally go ahead and test this sample. And in order to test this out, so we want to, of course, test multiplayer. And if we just hit, for example, play up here, we can see that we are indeed in an XR environment. We can move around and we can also potentially enter a room name. But of course, we want to test multiplayer. And for that, we would need kind of a second player, right? And in order to be able to test this, what we want to do is we want to install Parallel Sync, which is a free Unity plugin or asset, as how you wanna ever call it. And we're just gonna need to install that so that we can open up a second editor window and then test multiplayer and if the system is actually working out. In order to install Parallel Sync, you want to go to this GitHub address, as always, link in the video description. We want to go to releases and take the latest one that is not a pre-release. So this in our case is 1.5.2, and just click on this one to download. And then in my case, I simply put it into the Niantic multiplayer tutorial folder where also the project setting and the playback assets are, but you can potentially put that anywhere on your computer. It's only important that you know where it is, so we can just import it in our Unity project. So then back in Unity, we want to go to Assets, Import Package, Custom Package. Then we want to navigate to the correct folder and select the Parallel Sync package and click on Open. We want to import all the files. And once that has finished, we should see on the top bar in our options here, Parallel Sync, and open the Clones Manager. Then we want to go ahead and click Create New Clone. And this is going to essentially create a clone of our current project, which also will access the same files. Very important, do not do any changes within the clone. You'll just get an error message and it will kind of destroy things. So always do any changes into the game scenes or even to kind of scripts and anything, serialized fields and so on in the main project here and not within the clones. So then within the Clones Manager, let's open it in New Editor, and also be aware that sometimes things get messy, and in the worst case, what you want to do is you want to delete the current clone and create a new one. Because sometimes, again, if you accidentally do some changes in the clone, this might actually disrupt the project. You don't lose anything, but there will just be some weird error messages. And if you can't really figure out where they're coming from, this might be because of some mix-up here when changing stuff within the clone. But that will just be like a emergency I would say, emergency method, and you won't need to use that most of the time. All right, so then we can see that we do have a second editor window, and we can just essentially put them next to each other. Before we start testing how the count logic works, there's one more thing that we want to do for a bit later on, especially if we want to build to device. For that, we want to go to our build profiles. We want to open our player settings, and we also want to check the project validation. And this is something that we'll definitely need when later on building to device, but I think we might want to do this right now because we will get some kind of weird issues maybe later on. So for that, all we need to do is switch in between our platforms and click on Fix All. And that should essentially change up some settings so that later on, if we build to device, then we can very simply do that and don't get any error messages, especially if we're now testing in editor. We might also want to test on device. So I guess it's a good point in time to change these settings right now. All right, so then let's test what's actually happening. Let's increase the window size here a little bit. We click on play for both of these editors. We can go ahead and maybe on the left device, move a bit around, enter a room name. Let's simply do 1, 2, 3, 4, create a map, scan. Then we can look around to create a map. So we're going to move and simulate kind of moving the phone around. So waiting for a map, move around to localize map. And we can see that this is working. So then in the other room, let's also enter 1, 2, 3, 4 and load map. And we move around to localize. And now if we actually hit on place cube on the left device, you can see that we have a cube here, which will also appear on the right device. And in the same way, if we place it on the right device, we can see it's appearing on the left device. So this is essentially already a multiplayer working, and we can just imagine that it will work exactly the same way when we put this on our phones, which is pretty cool. We also have the delete cubes button, and so they all are going to simply disappear. Yeah, and this is already a pretty great starting point that we do have now to actually implement something. And in the following, we are going to take a deeper look on how the multiplayer settings and the whole multiplayer system of the Niantic Spatial SDK is working, and how we can use that to create real AR multiplayer games which are cross-platform. And again, if you're pretty interested, you can also essentially build this to device, and it will work exactly the same way. I also, by the way, made a tutorial on how you can build to device. So if you're interested in that, take a look in the video description into my Unity 6 Turbo tutorials. Now, when we talk about the cloud persistent sample here, so our AR multiplayer sample, it also says persistent in the name, right? And this is because it is not only multiplayer, but if we now essentially place a cube here, like that, so we have 2 cubes, right? And we now have the map. In this case, I started a new map, which is 2, 2, 2. If we now go ahead and disconnect from this map, and then we're going back and start over, and we again enter 2, 2, 2, and in this case, load map, we do actually can see that if we connect to the map, these cubes are back here. So this means in reality that we have a persistence, meaning that essentially, let's say you're on the phone and you scan your desk, and then you play some cubes, and then you come back a day later and you load the same map with the same code, then these cubes should be still there at the same position. However, this is all still experimental, and the problem about that is if lighting changes, or if maybe you move around the stuff that is on your desk, it might no longer kind of recognize this map as you only do one scan. So there's always the risk that you cannot reload a map that you once done. And for this tutorial, we are also just going to focus on the multiplayer aspect and less on the kind of persistence in between different sessions, but just as kind of an idea of what you can do as well. This is another feature that you can achieve essentially with the sample and with the logic of the new cloud persistence that we have in the latest versions of the ARDK. Next up, let's jump straight into the logic and create our AR game multiplayer prototype. For that, let's quickly close our clone here, because We don't need it for now, and we're just going to open up later on. And then let's go into our project, and in our samples, then we can go on the on-device persistence. And we can see that we do have some scripts here, which are also being used in the scene. So if we go to our cloud persistence, we can see that this is kind of all the logic that we are using also within the game. And as a first step, let's actually understand what is going on here. For that, let's open up the cloud persistence. So let's double click on that, and then it should open up in our IDE. So in my case, I'm using Rider here, but of course, Visual Studio Code or whatever you guys are using is totally fine as well. As a first step, let's understand how multiplayer is working within this project, because it is not the standard Unity netcode solution. Instead of that, it's a completely custom networking solution provided by Niantic. Let's get a rough understanding on how the cloud persistence script works by kind of understanding and going through the flow. So for that, we have the Unity project here on the left and kind of the code on the right. In that way, we can take a look at the logic and then kind of also understand what it actually does within the project. So first of all, in the start method, the setup create menu method is being called, and we're going to tear down some in-game menus, which is simply UI. But more importantly, we're going to create the load panel. And this is what we are seeing right here, right? So we have the create map button and the load map button, and we have those two options. And then we also have the input field for the room name. And we are able then to trigger these buttons. So let's first of all take a look on what happens if we click on the create map button. So we're going to set up the scan menu. And a method is being called to validate the room name. And so this is very simply checking if it kind of matches the allowed letters and numbers and so on, and if the length is not 0. So a pretty easy check here. And if that is valid, then we are going to set a room name. And then we also tear down the create menu, which is this menu that we'll see here. And we're going to set the scan map panel, so kind of the scan menu to true. And then we have the option to start scanning. So in our case, for example, what we do right here is we're going to enter a room name. We click create map, and then we do have the scan map panel that is being set to true, so active. And we're also going to save the room name, which was 222, in a variable. And then next up, what we can do is we can click on start scanning. And if we do that, what's going to happen is we're going to set a status text here. Also, of course, we then can't click on scan again. And we're also going to subscribe to a mapper, which is a second script that we are going to take a look at in a second, to an event, which is on mapping complete. Then we are going to set a timer of 5 seconds, and we're then also going to call a method, which is run mapping for, and gonna set the scan animation panel to true. So let's quickly jump into the mapper here in the run mapping for. So this is a new script, the mapper script that we are opening up. And what this script is essentially doing, as you can already see, well, it will start a coroutine run mapping for amount of seconds. And this is kind of the 5 seconds that we are defining here. And the goal is to kind of create a on-device map of the environment, which is a bit similar to, maybe imagine it like a 3D scan. I don't know if you guys have used Scaniverse or something yet, where you simply move your phone around and create, for example, a Gaussian splat or just a 3D representation of an object by moving around it. So this is essentially, roughly speaking, what it does here. So it will essentially enable or re-enable the AR device mapping manager, which is also in the scene, and start the mapping process. So it's going to create a new device map. It's going to start mapping. So then it's going to wait a few seconds and calls on stop mapping essentially. And if we go a bit up here, we can see that once we call the run mapping for seconds, we are going to subscribe to an event. in the device mapping manager. So if the device map has been finalized, for example, we're going to give it 5 seconds. After 5 seconds, it's going to create a map with the existing data. So we move the phone around and then we have a device map. Then we are going to trigger the on-device map finalized, which is then unsubscribing from this event. And then we're going to check whether we do have a valid map. So this is essentially then within the event carrying the AR device map, so kind of our 3D scan, if you want to say so. And if that has been valid, so if that has been, and this is also kind of a external method that we are calling here from the AR device map, where we can just check whether we have over 0 device map nodes. So this is all, of course, quite complex. We don't need to understand all of that entirely. But essentially, if we have a valid device map, then what we're going to do is we're going to call the onMapComplete method. We are, in our case, not actually calling the saved file because we don't use it, as we are using the cloud persistence, which is supposed to work in multiplayer and not only on one single device. So then we're calling onMappingComplete. And this is the method that we subscribe to here in our cloud persistence, right? So we say simply start scanning, then all of that happens, and we've beforehand subscribed to this method. And once that has been complete, if we are successful, then we're gonna set the essentially scanning panel to false. And then what we're gonna do is we first of all gonna join a data store manager. So let's quickly continue here on our left side. So again, we hit scan, then the scanning is starting through the mapper, and we're going to create a device map. And for 5 seconds, if we move around, then the device map is going to be created. And now we're essentially here where we say the mapping is complete. And we are also essentially joining the data store. And then we'll also kind of say send new map, clear on load, and wait for map to true. And this is kind of important, but we're going to talk about this in a second. First of all, let's take a look on what the data store manager is doing here, because what we just witnessed on the left side are actually already 2 steps that happened just right after each other. So first of all, we're going to join a room. And the data store manager is essentially one of the most important scripts and one of the most important logic pieces we do have within our Lightship networking, because this one is essentially handling all the networking. So we do have kind of a server that we use to store data with, for example, key value pairs. And if we, for example, want to move a character in our scene, and then all the other clients that join, so all the other players should be notified that this player is moving, and we also want to move it on the other devices, then this will go over the data store manager, and we kind of will subscribe to changes within the data store, within our database. So this is something that is independent of the mapping process that we'll do separately. We have a store name, which would be 222 or 1234 or whatever, and then essentially we're going to join the room by name with the room name, and then we're going to essentially get the room's data store and the room's networking. Data store is handling data such as, for example, the position of the players that move around. So this is could be seen as something like network variables that are being replicated through each client. And the networking is holding also some data such as the peer list, so all of the users that are within the current session, for example, and can also be used to send broadcasting messages. For example, if we do have some kind of option to fire bullets, then we don't need to store that somewhere. We just need to send a networking message to all the connected clients that player 1, for example, shoots a bullet. And if, let's say, some other client would join later on, then we won't necessarily need to mirror that to this other client, as maybe the bullet only has a lifespan of a second or something. So then we also here subscribe to the callbacks, which is being data store updated and network updated, which then again respond, for example, in this case, to the data that is being sent in between all the clients and the server. So this would be the map message, for example, if we send, in this case, the map that we just created, as well as in our case, we have the cube message, which will send a message that someone placed a cube. And then we can have a certain logic happening to kind of then, for example, instantiate cubes or load the map data. And we also have a reference to a tracker here, which is essentially used to do the co-localization, and then also have one persistent anchor that sits within our map, and then that kind of controls the position and kind of makes sure that all the clients have co-localized correctly, which means, in other words, that they all see the same objects in the same positions. And here we have the same thing with the network update. So we do have, in this case, just network connected and network shutdown. But later on, we can also send network messages, which we can talk about in a bit. And so finally, we're joining the network. So now the player has joined essentially a server. Back in the cloud persistent script, we then switch to the localized menu function. And here we once again actually have the validation of the room name, and we're going to talk about that in a bit. And this is because we do have also the join room function, or the join room button, that we haven't investigated the flow on yet, and this will skip some of the function we just did. And then once again, the validation of the room name. And this is once again more for the clients that are going to join. We're going to tear down some menus, and we once again then trying to localize here. And in our case, this is saying create or join data store, but this once again is for clients that will join later and haven't done all the logic we just went through. And as we can already see, we just set the is in room true earlier when we are the host, or kind of the person who creates the map. And so this method is just being skipped essentially on our host logic now, but we're going to set wait for map to true. And this is quite important because if we now scroll up to the update method, we then have some further logic that is going on. So the update method is always returning for as long as we haven't got the network running. Essentially didn't do anything until now. But we do have the send new map and wait for map booleans, variables. And if you remember that a bit further down, we actually set the variable to true. So we set up the scan menu. But yeah, so if we did the mapping complete, we're gonna set all of that to true. So the send new map is going to be set to true, and the wait for map is going to be set to true. And if we now go up in our update method, we would see that now these methods would be running if we are successfully connected to the data store manager. So we have send new map true, which would call in the data store manager save map to data store. And what this does is it will take the map that we created earlier in the mapper, as you might remember. It will essentially store this as a serialized data that we can then store on a server, and is going to go through the data store and set the data with the key map device map, and then set all the mapping data. So essentially our 3D scan that we kind of created earlier, which we talked about, will be set in the data store manager. And as we do have kind of this subscription here to the data store updated, this method will call on every client as well as on the host if we have uploaded the map. And we can already see that if the map has been uploaded and we then receive the method and this has the key map, then this will go down this path here to the if args.key.starts with. And this is essentially going to load the map into the scene and will then essentially enable the co-localization. So essentially what's happening is we're sending our 3D map to the cloud, we're saving this to the data store, and then it's also being loaded to each client that is either already in the session or is joining the session even a bit later on, because this data store updated kind of the network variables they're going to be immediately sent to each client that joins in order to synchronize all the data. And then if we have also the wait for map set to true, which we did, we are going to send it to false because we don't want to do this twice. Then we are going to do the localization. So for that, we are going to use the tracker and we are going to subscribe to the localized. And so this is essentially supposed to fire if the client or the host has localized with the current map. And then we are setting the tracker to start tracking. So this is essentially then again going to the AR persistent anchor manager. And first of all, though, we are going into the restart tracking data store method. And as we're not saving this on device, as we're doing essentially a cloud co-localization, we're going to again then restart the persistent anchor manager. We're going to set the device map to the device map that we have either downloaded or created. And we're going to track the anchor based on the device map payload. And what is essentially happening here is that we are using kind of the camera data of the phone and matching it with the 3D scan that we have created earlier. And then if this was successful, we should get the fire back from the tracker, which means that we are localized now. And that essentially means that we have successfully then co-localized from a client or the host with the existing 3D map, which means that all the clients and the host will see the same objects in the same position. And we'll also be able to position and create new objects. So when we're localized, then what's going to happen is it will set up the in-game menu, which is the buttons we're seeing right here. So the place, delete, back, and then we can start the game because we have done all kind of the prior work. Let's very briefly also talk about the client flow, which brings us back up to the setup create menu method. And here we would essentially click on the load map button, which would be kind of the same as joining an existing room or game. And so here we jump straight into the setup localized menu method, which skips a lot of the logic we've talked before. And here it absolutely makes sense that we will again kind of call the data store manager create or join data store. So here we are simply then joining the data store, which we created as a host pretty much. And then we simply wait for map and flag that to true. And we are not essentially sending anything. We're just waiting here. And if we then go up to the update method, we will then run the update method as soon as the network is running, but we won't send any map as we haven't flagged that to true, as we also didn't scan any map. So all we will do is execute this logic over here. And as we just saw earlier in the data store manager, if we are a client and we are joining the room, then we will automatically download the uploaded map as soon as it is available from the host and start tracking, which means that we're gonna start to match the image data of the client to the 3D scan of the host. And as soon as it is localized, then we will set up the in-game menu and the game will start, which is a lot less logic than what the host does, but is all we need to join the room and then co-localize so that all the objects are at the same positions for all players. All right, so enough talk. Let's go ahead and create some new logic and implement our AR game features. For that, let's exit the play mode here and set our code editor here to full screen. The first thing that we want to do is we want to kind of comment out all of that, because as we just discovered, this is essentially the game logic that we already had. And we don't need that. We don't want to just place cubes, but we want to rather do place a character and then move it around in the scene. So let's comment all of that out. And then begin to implement our own logic. And for that, let's begin by implementing plane detection in our Unity project. So I'm just going to quickly switch the view here. And then we want to go to the XR origin and we want to add an AR plane manager like that, as well as an AR raycast manager. We want to do a right click in our scene, XR, and create an AR default plane. And all we need to do then is to create a new folder in our assets. Let's create that and call it prefabs. Oh, and my Unity just crashed. So let's do a right click XR and create the AR default plane. Let's drag that into prefabs and let's delete it from our scene. Make sure to always save with Command or Control S. We can take the AR default plane and drag that into our AR plane manager. And then if we start the game, we should be able to see these planes popping up here. Yep, they do. And we're going to use those as a target for tapping or clicking to place our character a bit later on. So next up, we want to go to our samples and then open the on-device persistent sample. And in our scripts folder, we want to do a right click, create mono behavior script. And we want to call that place control player, like this, and open that up in our IDE. So in this script, we are going to place as well as move our player, or essentially trigger the movement for the player. Let's begin by creating a few serialized fields up here. So serialized field, private, and this is going to be a reference to the data store manager, which, as we just learned, is essentially carrying all of our networking logic. And then we also want to create a reference here. So serialize field, no, not to a game object, but to our AR raycast manager, like this. Then we also want to create a new list here, which we are going to use a bit later on, which is going to be of type AR raycast hit. And we're just going to call this one raycast hits. And we can just initialize that. All right, and then we still need to import this library here, up here. And then we also want to create a new bool that we are going to call player has been placed. Yeah, and I think we also want to follow the naming conventions here. All right, so then let's first of all delete these methods and simply start with the onEnable method. And first of all, going to enable the touch simulation in the new input system. So let's enable this one. And we also want to enable the enhanced touch support. So then next up, let's quickly create a new helper method that we are going to call handle player character placed, which is going to take a bool of type placed, and we're just gonna set player has been placed to this bool. So then we need to recreate the update method we just deleted. And within the update method, we want to first of all go ahead and say that if the data store manager, if that is null, so we're just going to do some checks here, or the data store manager and the network running is false. So if we don't have any networking, let's see what it suggests us here. Can be simplified. Yeah, I guess we can simply do that. And then in the data store manager, we also want to know whether the network is null. But I think for that, the data store manager does not have any property or something to access that. So let's quickly do this here in the data store manager. We do here have the networking and the data store, which are kind of the interfaces that we want to use to communicate within the database and within network messaging and so on. And what we want to quickly do here is we're gonna want to set the iNetworking to public in this case, and want to then add some accessors for the property. So a get and a private set, so that we can essentially then return the networking, but don't set it. So then back in our place control player, we can check whether the network is null. So in all of that cases, we just want to return. So then what we want to do is we want to essentially try to get a pointer position. So this could be then either from our mouse or from our touch input, as we want to test this on computer, but then also use it on our phones. So for that, we're going to create a new method, and we want to call this one try get pointer position. And it's going to take a few variables. So first of all, the pointer position, which is going to be a new variable that we're going to assign. The pointer ID. So this is also going to be a variable that we essentially create just within this method, as well as the info whether we do have a mouse input or a touch input. And if that is not going to return anything, so then we're just gonna return. So if this is going to return false, this essentially means that we haven't clicked or touched. So then let's quickly create this method a bit down below. So we're just gonna create the private bool and then try get pointer position. And it's going to take a vector2 pointer position, a pointer ID, as well as a isMouse input. So then the pointer position, we're going to set first of all to default, which I think is vector 2.0, but just be safe here. And the pointer ID is going to be then the pointer input module, which is from the event system. And we're going to take the mouse left ID. So essentially, if you're already using Unity, you might know that we did with the old input system, for example, always try to get mouse ID 0 or touch ID 0, which would be the index finger. And in order to do that with our current system, we want to, however, access essentially this pointer input module, which is an abstract class in Unity. And we also want to, first of all, set the isMouse input to false, so that we have our variables here already assigned. And then we want to go ahead and create a new for loop. So we're just going to say for int I equals 0. We're just going to say I is smaller than, and then we want to say touch, and then active touch dot count. And then we're going to say I++. So we're going to go through all the active touches. And this is actually not finding what I mean here, because we do have to do a little bit of changes in here. We don't actually want to take the Unity engine.touch up here. So in the import, when we import the libraries. But what we want to actually do is we want to go into the input system, and we want to go through the enhanced touch and then touch. And so now we're going to actually refer to this struct here, which is going to have some information about a touch input within the new input system of Unity. So then we want to say the active touch is touch.activeTouch and then I. And then we want to say if active touch face, if that is equal to the, and then we again want to go into the input system. So Unity engine dot, and then input system dot touch face. And in this case, we want to go to cancelled, or it is equal, so the active touch face is equal to, and then we kind of have the same thing here. We have the ended. So I'm not sure, did it actually import a touch face? Okay, yeah, so it already did that for us, which is pretty nice. Thanks for that. So if we have one of these touch phases here, and we just want to continue because we don't really care about those, we only want the touch phase begin, then we're going to say the pointer position. We want to set to the active touch dot screen position, and then the pointer ID going to be set to the active touch dot touch ID. By the way, this ID is mostly important because a bit later on we want to also check whether our touch is happening above some kind of UI element, which might be important later on. We're not going to do a lot of UI stuff here, but then we can check through the event system if our touch or our mouse click is above a UI element, and then not position our character or move our character. If, for example, we would want to click on a button, let's say an exit button, then we don't really want to also have this touch essentially telling our character to go somewhere. So this is about the active touches, and now we want to go also into the mouse. So mouse.current. And if that one is not equal to null, and if the mouse current and then the left button, if that is pressed, then we want to set the pointer position to mouse dot current dot position. Oops. And then we want to read value like this. And we want to say that if is mouse input is equal to true, and return true. And by the way, we also need to, of course, return true here, because we also have essentially a valid touch. And if we end up here and we don't have essentially any active touches or any mouse button pressed, we're going to return false and nothing happened. So back in the update method, so we first do some node checks here, and then we want to try to get a pointer position. So essentially try to figure out whether we do have either an active touch that is not being cancelled or ended, but beginning or maybe hold, or if we have a mouse button, and then we're just gonna set the pointer position, the ID, and whether it's mouse input, and then we can essentially go on and do a raycast from our screen to then find a position. So next up, we also want to work with the event system, as we've already talked about. So we're just going to go into the event system, and we already, first of all, want to check whether the event system.current, if that is not equal to null. I don't know actually if we do have an event system in our scene currently. Let's do a quick check. Yes, we do have the event system. We also, by the way, need to then replace it with the input system, as we use the new input system here. So let's also do that. It's good that we had a look here. All right, and then we want to say, so we want to create a new variable, and we want to call that pointer over UI. And we want to say that whether we have a mouse input. So do we have a mouse input? If so, then we want to go into the event system.current, and we want to say is pointer over game object, and we want to go into the pointer input module, and we want to take the k mouse left ID. Otherwise, if that is not the case, we do have the touch system. So again, in the event system current, and then we don't want to take the pointer, but the pointer, so we want to take the pointer ID. Oh, and by the way, we didn't name this correctly here. This is supposed to be the pointer ID. I think we named this correctly here, but not here. So let's fix that all of that is pointer ID. All right, and then we want to say that if pointer over UI, so if that is the case, we will return because we are over UI and we don't want to really then go on with that. And if not, we're gonna continue and work towards our raycasting. So then we want to say that if not, and again, a method that we're going to create in a second, if not, try raycast touch position. And we're going to take in here our pointer position, and our hit pose is going to be a variable that we, hit pose, that we're going to declare here. Then we're going to return. So now we are sure that, well, the user either clicked or pointed on the screen with their finger or touched on the screen with their finger. And then we are going to essentially do raycasting and check whether the touch position or essentially click position on the screen will, through a raycast, so through kind of a laser beam that we're going to shoot into our 3D world, will return a result. So essentially, if there might be an AR plane somewhere behind the touch. So for the try raycast touch position method, I'm going to also create a new one with a bool. So that's already pretty helpful here. So we do have, this is no, of course not our, but out. We do have the try raycast touch position taking a vector 2 as the touch position and out pose hit pose. And what we then want to do is we're going to say so the pose info. I'm going to call that just call that here pose info. Pose info is going to be default. And first of all, do check if we do not have a raycast manager. Just going to return false because we can't raycast anything. And we also want to make sure that the raycast hits that we defined above, we're going to clear this list, which we defined somewhere on the top. But other than that, we are going to go into our raycast, into our raycast manager and say raycast. Want to say take the touch position. Want to put in our raycast hits list. And very importantly, we also want to, as a trackable type, you want to say plane estimated, because otherwise we might actually have some weird bugs where a character will just fly in the scene and not actually sit on a plane. So they do have some options here that you can play around with, but essentially what we only want is we only want to place a character or move a character on the actual surface of an AR plane that we just saw a bit earlier. And this is, in my experience, the safest trackable type to use for that. And then we also want to say and the raycast hits count is greater than 0. So meaning that we do have more than 0 hits actually with the raycasting, right? So it's going to send a raycast through the AR planes, and the result should be over 0 because we're saving the raycast hits into our list. Then we want to save the pose information of our very first raycast hit and return true. And otherwise we are going to, return false, right? So now we do a raycast and check if there's actually some kind of AR plane or something essentially in our scene that will receive our hit or our click. All right, so then up here in the update method, the next thing that we want to do is we want to store our peer ID, because we're in a multiplayer game and we want to actually know which peer we are talking about, which peer we need to place, because the next step is essentially to send a message to the data store manager and make sure that then our peer is being placed. and ideally also the correct peer. So we want to go into our data store manager here, into the network, and we can get here the self-peer idea. By the way, it's also quite interesting to see what we can do here. We can, of course, check whether the network is running. We can go into the network. We can also call some methods here that we have defined, that have been defined already. And then within the network, we also have some more options. Oops. So we have the self-peer idea, we have the network state, and we also have the peer ID list, and we can then send data. So as you can see, the send data takes the list of the peer IDs, a tag, and the data, which is kind of this network messaging that we could do. So we can send data. This could be chat or maybe shooting or whatever, things that are only sent once and are not being replicated in a sense that it's being saved to a server, and then any joining client will sync up with those data information as soon as they join the data store or the room. But this data is only being sent once to each client that is currently being connected and is basically gone afterwards. So quite interesting. But let's go on. So we want to save the peer ID, and we want to say if not, and then player has been placed. So if we haven't placed our player already, then we will go into the data store manager, and we will then create a new method that we are already writing down here, which we're going to call place player character at position. So this method doesn't exist yet. And we're going to take the hit pose.position. We're not going to take the rotation, as we're just gonna place it straight up, and the peer idea. So we know which character is being placed, and we're going to return. But as we also have the option to move the character, we're gonna go into the data store manager, and if we have already placed a player, we want to call the method move player character to position. And we're going to again take the hit post position and the peer ID. Now we're doing this with the data store manager because this is our central point currently, which will handle all the data. And as we're in a multiplayer session and not a single player game, kind of moving characters or placing characters is something that is rather seen to be a network function, which needs to be replicated across all the devices. But of course, it would also be possible to kind of separate concerns, and might even be smart to do that in the future if the game gets more complex, so that we don't do everything over the data store manager. However, in our simple example scene here, it is a lot easier to do that and saves us a lot of time. But just as a heads up, if you want to make a more complex game, you might want to separate concerns that, for example, do placement or movement, and have a separate script handling that and then talking to the data store manager. So I think for now, that's fine for our control player script. And now let's move on and go to the data store manager, and let's implement the next functions over there. All right, so we're over here in our data store manager now, and our goal is to modify it so it will essentially be able to receive messages from our place control player script in order to place and move the player, and then also synchronize that to all the other clients that have essentially joined our room. For that, we want to begin up here and create actually a new struct. So we do already have a struct with object data, which was used to essentially synchronize the cube placement. However, we now want to create a new one for our player data. And so we're simply gonna create the public struct player data. And we want to then include in here the position. So we already, if we remember in our place control player script, we will set the position as well as the peer ID, or we want to set that in our current script. So we need to also have the vector 3 as the position, as well as a string, which is going to be the peer ID. And this is kind of a way that we can then serialize data and also send this to the other players. So then if we go a bit below, we also want to create a few more variables, which is going to be, first of all, a constant, so a private constant, the private const string, which is going to be called player key prefix. And this is going to be player. So we are talking about kind of the messages that we send. We just saw in the update method, essentially, if the data store updates, then we will kind of sort out what we want to do by taking a look at the prefix. And we had the map over there, and we're also going to now have the player. And then we're also going to add a new const, which is going to be the player data store index, which is going to be 6. And the later on that we'll also need is the player move speed. So again, another const float, which is going to be the player move speed. And we're going to set this one to 4 and make sure that this is for f, because we use a float here. So then we also want to create a few dictionaries, and we want to here store the player instances which have been spawned, as well as the player target positions. Again, we're doing all of this currently in the data store manager, as it's the easiest and straightforward way for a simple prototype. But if you would be looking for maybe a more complex AR game, you might want to do a bit more of concern separation and have another script that does some of the logic that we're doing here right now. But I think for now, it's again fine for the intended purposes. So we want to create a private read-only dictionary. And this is going to take a string and a game object. And we want to call this one player instances. And this is going to be a new dictionary, and we can simply say new here. And then we want to create one more private read-only dictionary. And this one is going to be of type string and vector 3. And it's going to take the player target positions. And again, we want to declare this as a new dictionary. So then finally, let's create some more serialized fields, because we want to declare game object as our player prefab. And we also want to have, let's also create 2 material slots here, which will be the player 1 material, as well as, the player 2 material, so that we can then assign those. And we're now talking about 2 players, but if you want to test it with more players, you can also, of course, add as many materials as you like. So then let's scroll a bit down to the data store updated method. And here, first of all, we want to modify the if statement and say if not args.starts with, and yes, we do have the player, but we can also simply take the player key prefix. So if not our key starts with the player key prefix, we want to go back, because we do now have essentially one more prefix to look out for. So then all we need to do in the method below here is, well, first of all, I think we can delete the cube method, as we don't really need that anymore. And we do have still the map that is essential in order to do the co-localization. But then we can also go ahead and add a return statement here, which is easier sometimes than the else if statements. And then we want to say if args dot key dot starts with, and then we have our player key prefix. So if this is the case, then we want to create a new variable that we want to call player data, which is going to then go ahead into the JSON utility from JSON. So as we send this over network, this is all being essentially sent as JSON files here. We're going to go and take our player data and put in the data as a string. So we're essentially then retrieving from our data that we sent a new struct, which is going to contain the player data. And then we will create a new method that we will already call, which we want to call handle player data store date. And we want to put in our key, as well as the player data, and then we want to return. All right, so then let's create our new method here. So let's create a private void handle player data store update, and we want to put in string, and we want to call this one data store key and the player data. All right, so in this method, the first thing that we want to do is, first of all, make sure that the player instance actually exists, or if not, we might want to spawn a new one. And for that, we are going to, first of all, create a new variable that we want to call player instance. And then we will create a new method a bit later on that we want to call ensure player instance. And we will put in our data store key as well as the player data.peerID. So we will implement that in a second. And if we have no player instance, in our case, we are simply going to return. You're going to see how that makes sense in a second. And then we also want to create a new variable that we're going to call isFirstUpdate. And then we want to say if not the player target positions dot contains key, and we're going to take the data store key. Then we are going to set the player target position of the data store key to the player data.position. So essentially what we're doing here is that if we don't have a player instance, this is going to create a player instance at the position of our player data, so a spawn. However, if we have already a player instance, which is if we already placed a player, then we are going to essentially set positions in our player target positions, which will be connected to the data store key, which is essentially the peer ID. And so then our data store manager can, instead of instantiating a player, move the player to a specific position while also synchronizing that across all the devices. So then if this is our first update, then we want to set the player instance dot transform. So this is going to be a game object, and the local position to the player data dot position. So this means that we essentially spawn the player instance, and we then immediately want to set the position. So we don't want really any kind of lerp or slow animation, because we want to essentially beam the player instance to the first position. So after that, we will call the method apply player material, which is a method we're also going to create in a second, which we're gonna put in the player instance, as well as the data store key and the player data dot peer ID. Then we're going to say if our network does not equal null. So if we do have a network connection, and the data store key is equal to, and we once again want to make one more method later on, which is the get player key. And then the network dot self peer ID. So we do want to make sure that we have some ownership here. And then we are going to invoke a new event that we'll also create in a second and call that on player character placed. And we're simply going to invoke that. And it's going to carry true as a data. So then let's quickly create the methods that we already referenced here. So beginning with the ensure player instance. So this method is going to be private and it's going to return a game object. And it's going to take the data store key, as well as we will call this serialized peer ID as an input. And then what it's going to do, it's going to go into our read-only list of player instances or dictionary. And we're going to tap into the try-get-value method with our data store key. And we're going to create a new variable on the fly that we are calling existing instance. And then we also want to make sure that existing instance is true. And if that's the case, then we're going to return it, because this means that we already spawned a player and we can just return the value back. However, if that is not going to return any value, then that means we haven't spawned the player yet. So we need to then spawn the player, but also make sure that we do actually have a player prefab. And if we don't, we could simply return null. And we can also go ahead and do like a debug log error player prefab not set. And then otherwise, we can go ahead and create an instance, which is going to be the instantiated player prefab like this. And then we're going to name the instance, which is going to be the data store key. And then we want to go into the instance, transform, set parent. And then we're going to set the parent to our tracker.anchor. And as we remember, the tracker is essentially the thing that will co-localize and make sure that when we have created a map, it's at the same position for each client. Then we also want to set false to the world position stays. So we don't really want to keep the current world position or anything of our object, as we're just instantiating it. So then we want to go into the player instances dictionary and set for the data store key our instance. So we have a reference to that and will not spawn it again. And then we will also again call our method that we'll create in a second, which will be the apply player material method. And we're going to put into that our instance, as well as actually the data store key, as well as the serialized peer ID. And we're gonna then return the instance. All right, so the next up, I think it's time to create the apply player material method. So we actually misspelled that here, like that. So let's create the apply player material method. This one is going to be a private void, and it's going to take a game object in form of the player instance, as well as a string in form of the data store key, and we have the serialized peer ID here as well. So then let's first make sure that if we don't have the player instance, then we're gonna return. And then we're also gonna create a new variable that we're gonna call the renderer. And that will be the player instance get component renderer. So that we can then change the material. And if we don't have a renderer, Just gonna also create kind of a debug log warning. And so we don't have a renderer. And we're just gonna return. Might already be useful to also save what kind of data store key we have here for the player instance, but as we only have 2, that is not absolutely necessary. So then let's create a new variable that we will call material to apply. And this one is going to get material for peer, and yet another method that we will implement a bit later on, and we're going to pass in the serialized peer ID. And so then we're going to say if not material to apply. So if we haven't found anything, also want to put a debug log warning. And maybe the code completion has a smart idea. Do we have a smart idea? Could not find any material for peer. Yep, that sounds great. And let's simply return here. And otherwise, we're going to go into the renderer, the shared material, and we're going to set it to the material to apply. All right. So let's go up. We still have some methods to implement here, which would be the get player key and the on player character placed event action or event. So the get player key method is actually straight simple. So all we need is to return a string, and we're going to take a peer ID as an input. And then we're simply going to return, and in this case we want to say the player key prefix, so player, and then the peer ID, and we can put that to string. And we could also essentially put all of that in a string, like this. Oops. And then make sure that we have the curly brackets here, so that we do actually have a full string with these variables in here. So then let's also create the onPlayer character placed event. Can create that somewhere up here. And we want to define a public event action bool. And simply leave it at that for now. Another method we need to implement was the get material for peer method. So let's do that next. So we're going to do a private material, get material for peer. And we're going to take the serialized peer ID. And then at first we want to say if, so string is null or empty. So just do a quick null check here for the serialized peer ID. Then we're just gonna return, for example, the player to material. And otherwise, we can simply say that we're gonna create a bool, and we're gonna call that one use primary material, because in our example here, we only deal really with 2 players. That's kind of what we are building here. You can of course do more, but so all we need to do here is the serialized peer ID, is that equal to, and then we can go to our network and peer IDs, so the whole list of all our peers, and 0 to string. So essentially, are we the player 0, which is always going to be the host? So if that is true, then, so if you use primary material is true, then we're going to return player 1 material, and otherwise we are player 2. All right. Now, as we can see by our red squiggly line here, we still haven't implemented the 2 methods which will actually trigger the place player and move player logic. So let's do that next up. And by the way, we don't have that much more logic to implement, so we're almost done. So stay with me a little bit. We have almost finished our amazing AR multiplayer prototype, which is going to be so cool. So definitely make sure to stick around until we have made it. So first of all, let's create 2 new public methods for that. And we can, for example, go up here to the other public methods. And we want to call this one then, I think it was place player character at position, was it? I think so. Taking the hit position and the peer ID. And of course, we need to define the return type, which is nothing, so void. And then next up, we want to go into the public, create a public void move player character to position. And once again, we have the same values here. You can see the red squiggly line disappeared in the place control player script. And so here we can simply call set player character transform method that we're going to define a bit later on. And here we want to put in the hit position the peer ID. And we also want to define whether this is the initial placement, and in our case this is true. And we here also want to simply call the same method under the hood, which is also going to be the set player character transform. And it's not going to be the initial placement, so we're going to set that to false. All right, so we're going to now create this method in which all of the other methods are going to make more sense even. So we're going to create the private void, and then we make the set player character transform, taking the vector 3, and yeah, we already have our code completion here helping. However, the bool, we want to define whether this is initial placement, like this. And we're going to first of all check whether our data store, of course, is null. And if that's the case, just going to return. Could also create some kind of debug log warning. And then if that is the case, we want to take, so if that is not null, we want to also store our anchor here, which is tracker.anchor. And if that is essentially also not null, so here once again, let's do a debug log warning, return, oops, return. Then we want to actually store the peer ID string, which is going to be the peer ID and then toString. And we're also going to store the data store key, which we can now call our getPlayerKey method that we created. And we can also get the local position, which is going to be from the anchor the inverse transform point, which, as we can see, is transitioning the point from the world space to the local space. And we need that because our raycast position that we created in the other script will be in world position, of course. So we're going to put the hit position here, and we're going to take the player instance, which we're going to use our ensure player instance method for, and the data store key, as well as the peer ID toString. And then if we don't have a player instance, we're just going to return, because we want to set here the player character transform. And if we don't have an instance, we cannot do that. But of course, we in the player instance, we make sure that we're going to have a player instance. So this is just kind of a safety net here. So we want to say that if the player instance and then transform and the parent doesn't equal the anchor, so also another safety net here, we want to make sure that the player instance parent is the anchor. We also don't want to have the world position to stay. And then we're also gonna create a new variable, which we will call should_snap, which is going to essentially store if our player target position, so this is what we're going to use for movement, if that contains the key of the data store key or the initial placement. So if that is the case, and then we are going to go ahead into the player target positions, and we're going to set the data store key, so the key of our, essentially of our character, to the local position. Then we also want to call the apply player material for the player instance, the data store key, and the peer ID string. So we want to put on the material on the player. And then we want to create a new variable that we're going to call player data, which is going to be a new player data. We want to set the position to the local position and the peer ID to the peer ID string. And so what we're doing right now is essentially we are creating a player locally or defining a waypoint for a player locally. And then we are going to essentially broadcast it or set it to the database so that it can then be replicated. And what we've done before this method is actually implementing the replication of the player. So next up, we're going to create the variable that we will call payload, so data that is being essentially sent over the internet. And we want to use encoding, Unicode, get bytes. And we're going to go into the JSON utility to JSON and going to put the player data in here. Then we want to go into the data store and set data and take the player data store index and the data store key, as well as the payload. And if it's the initial placement, we also want to invoke the on player character placed to true, so that we do not place a character once again. So one thing we need to still add to this method is, of course, if we should snap, meaning that if we have the initial placement or if for some reason we don't have the target position, then what we want to do here is, of course, go into the player instance, transform local position, and set this one immediately to the local position so that we don't have some kind of animation or lerping. Now then what we else need to do is to create an update method so that we do actually have the movement of any player going from point A to point B. And so in the update method, we first of all want to say that if the player target positions, if the count is 0, so if you don't have anywhere to go, essentially, we're just gonna return. Then we want to, of course, get a reference to our anchor. So we're just going to be the tracker anchor. And then we want to get a step, which would be the player movement speed, player move speed that we created earlier, multiplied by time.delta time. And if our step is smaller than 0f for some reason, then we're just going to return, because we then will not move anything. Then we want to say for each, and we want to go through the key value pairs in the player target positions. So if we have somewhere to go, essentially, we want to first of all check whether the player instances, and we want to try get value of the key value pair .key. If we actually do have no player instance here for some reason, we want to continue because we don't have any player to move. So if we don't have any player instance, then we're also gonna continue. And also if we don't have any anchor, of course, we also simply want to say instance, player instance, transform local position equals to the kvp.value. I also want to continue. But these are all kind of the edge cases, right? And we now want to actually go ahead and do the movement. So let's go ahead and do the target world is equal to the anchor.transform point. And we want to go for the kvp.value. There's one bracket too much, or bracket pair too much. And then we want to say our current world is our essentially the instance or player instance, and then the transform.position. And so if the current world position, if this minus our target world position, I'm gonna take here, so here we actually need another pair of brackets because we want to potentially take the square root magnitude. But if that is below 0.0001f, so if we're almost, let's say, we're almost at our goal, then we just want to essentially set our player instance .transform.position to our target world position and continue. And finally, we want to create a new variable, which will be the new world, so the new world position. And that is going to be the vector3 dot move towards, and we're going to say the current world position and the target world position with the steps. So otherwise we're just moving towards the position, and then going to take the player instance, transform, position, new world. So in this way, we're going to move the player object towards the goal. Well, if there's a player object to move. And this is going to happen within the update method. By the way, there's one little thing that we want to change here in the get player method. And this is that we don't want a plus here, but we actually want to have the player key prefix and then immediately the peer ID to string. All right, so one more thing we want to do here on the enable method is actually go into the data store manager, because we haven't done that already, if that is not equal to null. Then we want to say data store manager on player character placed, which we now do have, and we want to handle player character placed. And if the data store manager dot network, if that does not equal to null, which would only happen if essentially we join a bit later, then the player has been placed equals to the data store manager dot, and we're gonna implement the has player for peer. And so we're gonna put the data store manager dot network dot self peer ID in here. And then in the data store manager, we wanna create the public method here, somewhere at the top. So public has player for peer. I'm gonna put in the peer ID. And then we're gonna create a variable that we wanna call key, get player key, put in the peer ID. Then we wanna say if the player instances dot try get value from the key, and we wanna essentially create a new variable here, which we're gonna call instance, for example. And then instance is not equal to null. We want to return true. And otherwise, we want to go into our player instances, and we want to remove. And we want to remove our key. And then we're going to go into the player target positions and also going to remove our key and return false. And by the way, yeah, of course, we need to put in a bool here as a return. And of course, here we want to make sure that if we don't have a player instance, then we just want to continue, means kind of skipping this loop, and not the other way around. And of course, here we don't want to set to the local Euler angles, but to the local position. I guess there was some kind of auto-completion. It can be good. It can also be, well, not so good, but luckily we found the issue. Back in the editor, we want to assign our new script. So we can create a new game object and maybe call this place control player. And then in our project, we can simply take the place control player script and drag it here. And then we can drag in the XR origin for the raycast manager and the cloud persistent for the data store manager. In the cloud persistence, we of course have to assign the player prefab and the player materials. So for that, let's go into the scene view and create a very simple 3D object, such as a capsule. And we can simply, for example, call this one player prefab, set down the scale to 0.2, for example, and then make sure that we will set it up for 0.2 on the Y. Then we can drag this into our prefabs folder. And next up, we want to delete it from the scene and create two materials. So first of all, a new folder. And then we want to call this one materials and set in two new materials. So create material and player one material, duplicate it, or create a new one and player two material. And player one, we are going to set to blue. And player two, we are going to set to yellow. So then let's assign all of this in our cloud persistent data store manager. So player one, player two material, as well as the player prefab, like this. And if we test this in our Unity editor now, clicking play and having the parasync copy open, we can enter our room name, we can create the map, scan, look around, and we can also see that the whole plane detection is working great. Then we have the usual flow, and after localizing and doing the same thing then on the client, so entering the correct room name, it's very important to remember that. And then localizing, we can see that when tapping on any surface, let's say on the table here, yep, the blue player is placing and is also moving around, as we can see. And the same goes for the client. So things are working quite well. We can easily place and move players. So as some final advice to make placement and moving on the device a little easier, what we can do for now is go into the XR origin, the main camera, and actually disable the AR occlusion by disabling the light chip occlusion extension, which doesn't work with Unity 6 anyways at the current moment, and setting the occlusion preference mode to no occlusion. And moreover, in our place control player script, we want to go to the try raycast touch position method and then maybe reset the trackable type from plain estimated to all types. So this we set especially because in the editor there's sometimes this weird behavior where an object will float in the air. However, on the device we have a better depth estimation and map, which will also improve then the raycast hit quality. And so we don't run into this issue on the device. But before we can build, let's double check our project validation. And it seems that For some reason, some of the settings need to be set. So we want to click on Fix All. I think we've done this before, but for some reason, kind of seem to not have logged that actually for whatever reason. But when the project validation is fine, we can then close the window and go into our build profiles and then go to build and then simply choose a folder and click choose. In this case, I'm on iOS here first, but after that, I will do the exact same thing for Android. So after the iOS build has finished, I'm going to select Android and gonna click on switch platform. And after that has finished, we can also simply go to build. Then we can select a new folder and call this something like multiplayer AR and simply click on save. And then it's going to create an APK for us. And here it's actually telling us that we do have still active input handling set to both, which we don't want. We want to cancel our build here and quickly set this to the new input system. This should have usually been done automatically by the project validation, but it's not a problem. We're going to quickly solve that by going to the player settings and then player Android, and then we're going to scroll down and then we're going to set active input handling to the input system package new. Here we need to restart the editor. And once that has finished, we should now see that the active input handling is set to the input system package. And there's one more error, it seems, within the player settings, which is that seemingly Android does not like these numbers and dots here. So we're just gonna delete those within the player settings and the Android settings where we just were. And then just gonna close the window and try our luck once more. Sometimes just these small issues, but they're usually quickly fixed. And yes, as we can see, the build has been completed and we can now load the app onto our Android phone as well. And finally, we can see that everything is working on the device as it should, which is pretty awesome. And we now finished our AR multiplayer experience. Whew, alright, but that's it for this video. It's been quite long, but you stayed all the way till the end, which is pretty honorable, and I hope that it was interesting and insightful and you learned something. Let me know what kind of shared AR experience you want to build in the comments below, but until then, as always, thanks a lot for watching and see you next time.